Alright, in this next warm-up exercise for frame and machine analysis, we have a pretty complex kind of situation here. And that is we've got 1, 2, 3, 4, 5, that's right, 5 members that are all pin connected in a fairly complex arrangement. Now it's 5, not 6 or 7, because this vertical member GBEH is not joint to joint to joint, but one long continuous member, right, which is suggested to us by not seeing little circles that indicate that member GB just stops there. But no. It is suggested that we've got these overlapping kinds of situations, the straight lines going all the way through. Yeah, the subtleties of these drawings will be crucial in your interpretation of the system. And indeed, any other way to try to interpret this system, you'll end up with a system that's not stable. Right, so we actually have 5 members, and you see down below 1, 2, 3, 4, 5. That's right. 1, 2, 3, 4, 5 members are shown down below, and we got to think about now starting to pull these pins and trying to figure out what's going on. I suggest that we start with member ABC because that's where the load is applied, and we're going to do a variety of things here. We're not just going to come along and say, well, at B there's a pin, and so we'll put a horizontal vertical component. We can do that, but I don't know what direction they are, so let's try to figure out what some of these directions might be. For instance, if this is point B and I sum moments right about point B due to this 900 Newton load, then I know, given the equal moment arms that we've got from AB and B to BC, that this force over here at A also has to be 900 newtons going down. Now that is on the end of the member, not at the joint itself. Really close, but not quite. Right? And so you'll see that in a second here when I go look at this reaction at A about why I'm calling it somehow a little bit different there. Right? Now, I don't know what's going on with the two X components here other than I know they're equal and opposite in direction, but I'm just going to leave that go for now. Right? But note here, sum of forces in the Y, or you could sum moments about point A, you could find out that BY has to be equal to 1800 newtons. And you say, well, why didn't you call that BY prime? Well, because in this case, with GBEH, this B is not a support. It is just a pin that goes in between two members. And I'm going to come down here immediately to point B on this long vertical member, and I'm going to turn this 1800 around in the direction that member ABC puts a force onto GBH. Right? So these two need to be equal and opposite, because when we put them back together they should vectorially disappear. We're also going to have a potential horizontal force there. I haven't figured out what that is yet, but I don't want that to go completely away. Right? Alright, well, that's a little bit of what's going on here, but this gets even more complex, right? I don't know what's going on yet with AX nor BX, other than I know that they're going to be equal and opposite. Let's look at this member DEF. No applied force, so all we have is a possible vertical horizontal at where the pins are located at. Right? Well, wait a minute though. That's a pin-connected member, and if I sum moments about D, then I'll know that the things that, well, that has to be 0, right? And if I sum moments about E, well, then that vertical or perpendicular has to be 0. So this is a two-force member. Pin, pin. Doesn't have to be at its ends. It just has, it's got 2 pins only, and it's got no other applied forces to it other than at those pins. So that has to be a two-force member. Right? Again, I don't know anything about the X component, and that's at a support, so I'm going to call that dx prime. And then I do know that EX will be opposite of this dx prime, but that's all I'll know. So let's go and talk about those little pieces here, and let's actually start with this support right at D. And I'm going to again superimpose things right off on top of the global drawing. If we were to sum moments about point A, then the 900 newtons wants to spin about in a clockwise fashion about point A, and that means that our roller support here at D, our true dx a support reaction has to be going to the right in order to make that happen, right? And notice the moment arm of 900 is 400. The dx has a moment arm of 300. That means it's closer, so that means see, that would be 4/3 of 900, so that would actually end up being 1200. I just some moments in my head about point A, but for sure that direction has to be that 1200. I'm not going to show that down here, right? I want to finish off the reactions first. So AX will, of course, will be opposite of that dx that we just found, so that's also 1200. And the only vertical reaction we end up here is AY, and that would, of course, have to be equal to 900 for translational equilibrium. So we get both translational x and y, and we get sum of moments being satisfied here, and all that has to equal to 0. Right, now let's go back and let's look at this little support here at D. Right? And so I'm going to show, in this case, a little support, and there we go. There's a little thing that we were indicating was the support. And so we've got our global reaction of 1200 acting to the right on that thing. And then we have this member DEF. Now, we already know that that 0 for the dy prime is there, but we also know that we've got a dx prime. See, that's coming from the member DEF going into that support. That's why I've differentiated these a little bit. Now look at what happens with DH, right? Pin connected member. Wait. Pin connected member, no loads applied to it other than at the pins. That's got to be a two-force member. Alright, well, if that's the case, then, but wait, by summation of forces in the y, it's the only thing with a y prime, right? This thing was 0, so it's not there. So that makes then DH equal to a 0 force member. It's not, in this special case, it's not only a 2-force member, it's a 0 force member, right? And that makes dx prime then somewhat trivial. That's got to be 1200 acting to the left on the support. That means the support acts to the right on the member, and that means over at E we've got to get EX equal to 1200 newtons also acting to the left. We just found another one. We have to come over here. I don't know if you can see this. Yeah, barely. There's E. We just found out that is acting to the right at 1200. We know the vertical is 0 here, so I'm not going to show anything. And, well, yeah, I guess I will. I'll just show it like that. That's 0. And we know down here, DH, that was a 0 force member. Wow, that's kind of interesting. Didn't expect to get all this all at once. Right? So that almost gives us a complete free body diagram from GBH, but hey, wait a minute, we got another member here. AG is going to be, it's a 2-force member too, right? Pin connected, no applied load to the member itself, so it's got to be 2-force in between. Now, when we look at this free body diagram, note what's going to happen here. We've got an 1800 going down, so that means the vertical component of AG has to be going up, and actually now we know it's going to be 1800s in that component. And then we also have then the 1200 going to the right. Notice the ratio here that we have on the sides of that potential triangle. I don't like this. Why do I not like this? I thought I was in a conundrum here, but we're okay. Look at this. 1800 going down means that the y component of AG would have to be 1800 going up. It's a 3, 4, 5 triangle. I don't know what that means about the hypotenuse, but it does mean it's horizontal components acting to the right. The 1200 goes to the right, but we do have a possibility of a reaction or a force at BX, and that's going to be some big number, the sum of both the AGX component and the 1200. And it means when we come up to this one here, BX has got to be going that direction, and A prime X is going that direction. And let's see what that does to us at the support at A. Right? So we found a bunch of things out here. We need to kind of catch up a little bit. We found out that the diagonal AG is in compression. We know how to go find it. We know that its vertical component is 1800. We found that down on GBAH. But now let's go do a little free body diagram of the support at A. And that one then is got, we know we have a global reaction 900 going up. We know we have a global reaction to the left of 1200. We know that we've got AG coming in at a 3, 4, 5 diagonal coming downwards to the left, pushing on the joint. We know that ABC is going to then, let's see, the support is causing a 900 newtons on that member, so the member is causing 900 newtons. That's A prime Y. And now there is A prime X going this way. And now you hope when you do all the math that that will actually sum to be equal to 0. If not, we know we've made a mistake somewhere along the way. Right? Wow, that's a lot. Oh, hey, this is kind of cool. Look at this. 900 plus 900 is 1800. And we said the vertical component of AG was 1800. Oh, that's starting to sound really good, that this is actually working out the way it should be once we start to do all the math. But note how complex the free body diagrams became. Right? Not really the free body diagrams, but figuring out what to do with them. We had to draw sort of almost all 5 members free body diagrams and start to look at little pieces, look at the global equations of equilibrium and free body diagram together, and pull all that together at various little pieces, chopping away at it little bits at a time to begin to figure out how to start to find out the various forces that are in each of the components. Yeah, they're complex. This is not easy.